All right, I think we are good to go. I'll start off by thanking our sponsors of this conference. They're important companies that help us keep this conference free to attend, so hope you go down and visit their booths. I'm Josette Lewis. I'm Vice President and Chief Scientific Officer here at the Almond Board of California. And I have had the pleasure of covering the issue of honeybees, pollination, and pollinators for my time with the almond industry. And we have three really important presentations here today, so I'm glad to see good participation. First will be Dr. Elina Niño talking about research that we funded to look at stocking rates for self-compatible varieties. We know that these varieties have been out in the industry now for over 10 years, with Independence being the first one. And there's a lot of information and misinformation about whether or not you need bees. So we, as is the Almond Board's way, ensured that we funded some scientific research to get science-based information on how to ensure you get the best yields with self-compatible varieties. And then we'll go to Matt Beekman, who's a beekeeper. You're all here because honeybees are an important input to growing almonds. And it's important that we understand what's going on the other side of that industry. They have been facing a lot of significant challenges, not dissimilar to our own industry, some for the same reasons: labor availability, labor costs, and some for some very different reasons having to do with threats to honeybees. So important to understand what is behind the price that you pay for pollination services. So really happy to have Matt here. And then we'll finish with Alexi Rodriguez, who is the CEO of the Almond Alliance, an important partner of the Almond Board and the almond industry. And she will talk about a native pollinator conservation agreement that will be hopefully available for all almond growers and other crop growers to join next year. We hope next year is the year. This has been a long time in the making, and it offers some important protection for almond growers in the light of potential endangered species listings. So 3 really important topics all around pollination, and I'll turn it over to Dr. Niño to talk about stocking rates in self-compatible varieties.
Thank you, Josette. Everybody can hear me, right? Okay. My teeth might get a little chattery because it's kind of cold in here, so forgive me for that. But we are going to start off by pretty obvious. I can't see. I don't have the PowerPoint is it up? Okay, now it's up, right? So you can see some bees there flying on almond flowers, and I think that's a video taken by one of our collaborators, Bernardo Niño, when we were doing this research on self-compatible varieties. And of course, I don't need to tell anybody here how important honeybees are, but just in case you forgot, right, I just wanted to mention that honeybees are still considered to be the primary and the most important managed pollinator because of the characteristics that they do have. One of them being you can actually pick them up, put them in a box, pick them up, and truck them across the country. And for almond growers, that is very important because in California, we don't actually have enough of honeybees to cover the almond pollination successfully, right? And of course, they have a large number of foragers inside the colony, as well as they exhibit resource constancy, which is quite important. If you're putting them on a crop, they will stay in that crop until they deplete the nutrition, right? They deplete the food supply, and then they move on to something else. So it's really important to or the honeybees, again, are very important for pollination. Okay. Almonds, of course, are not the only crop that's being pollinated in California and elsewhere, because we are in California, we're talking about California, right? So for example, alfalfa seed production, cherries, melons, a lot of the seed production is covered by honeybees as well. And then, of course, honeybees are used for production of honey, and California continues to be second or third highest honey production state in the country. And this is what I was talking about earlier. So the start of the pollination cycle for the beekeepers is in almonds, right? So that's mid-February. Colonies might already be in the state of California for almond pollination. Estimated there are about 2.5 to 2.7 million colonies in the United States. In California, there are only about 600,000 resident colonies. And this is a survey that is continuously being taken by the USDA. Statistical services, so these are the numbers that I'm reporting to you. Don't come at me, right? I didn't process these numbers because they do vary from year to year, and depending on whether it's an annual survey or the ag survey that they do every 5 years. But this is about the number of colonies that we have, and of course that number increases significantly early in January when we take this survey because the colonies are here for almond pollination. Of course, there are reports of high colony losses continuously for the past about, I would say, almost 20 years. Beekeepers have been reporting really high losses, and Matt's going to talk more about that. But this past year, we had particularly bad colony losses, and the commercial beekeepers have reported about 62% losses. So it's quite devastating, and it's becoming unsustainable for the beekeepers. Again, Matt's going to cover that in more detail. Stocking rate recommendations are varying from crop to crop, right? You are almond growers, so are interested in almond stocking rates. You do, as an almond grower, spend quite a bit of money on hive rental, of course, but without honeybees, you really wouldn't have your almonds, right? So that was the question. What are actually the stocking rates that we need for specifically self-fertile varieties of almonds? And that is the research that has been going on for a couple of decades now. I didn't realize, I actually just looked it up fairly recently, and when I looked it up, the Independence variety has been out since 2008, and we're still kind of trying to figure out what the stocking rates are specifically for that variety. And of course, there are newer varieties that have come out, Shasta, Yorzane, did I pronounce that right? Yorzani. So there are several others that are coming out, and of course, that is going to be the question that we're going to hopefully continue to work on to help everybody out. Okay. So the specific project that I will cover, it actually has been finally published, right? So here's a paper. I forgot to put the title up here in the slides, but I do have the paper. I can leave it up here somewhere on top if you wanted to come by and take a photo of it so you can look it up later. It is open source, so you can go and learn more about it, right? You can actually sit down with the paper and process all of the details. But this study was done over 2 years. And we had slightly different goals for the 2 years that we've been working on this. And we worked with our collaborators, Dr. Arati Seshadri from USDA. She's now in Mississippi, but she was in Davis at that point. Zach Ellis, who is an almond grower, and then Dr. Angie Delaluz. She is with the Bee Flow Company. Okay, so this is kind of the reason why we wanted to start working on this question. There was a lot of talk about how self-fertile varieties don't need no stinking bees, and I think that's still my favorite title, right? Bees, these self-fertile varieties don't need any bees. So we wanted to go ahead and really ask that question: do they need bees, or are we just saying that they don't need bees to make everybody happy? It's like, oh, I don't have to rent bees, I don't have to spend money, I'm still going to get yield. So we went out and we did, as I said, the study over the 2 years. And we essentially, what we did, we covered the almond trees with a cage, and then of course we also had trees that were open. In year 2, Dr. Delaluz has actually done an additional group where they just had a shade over the tree, but it was open on all of the 4 sides, just to make sure that there is no impact from removing that sunlight right on the tree. So there was no impact of that, actually. And then in year 2020, we only had, as I mentioned, excluded trees with the cage, open trees, and then in 2021, we had a variety of treatments. So we had excluded trees, open trees, shaded trees, and then we also had 0, 1, and 2 stocking rates, right? So 0 hives, 1 hive, and 2 hives. And here, just for your reference, we are fully aware that there is some ambient presence of the bees. A lot of these independent orchards, or a lot of the self-fertile orchards, are actually embedded within the conventional variety orchards. So as the growers rent these bees for the conventional varieties of trees, right, there will be some spillover. So we estimated about half a hive per acre ambient presence of bees, right? Okay. So straight to the results, right? These are the results that we did get in 2020. And to be honest, I really didn't believe these results because it's really rare that the results are so clear when you do research. So I panicked as a researcher, like, oh my God. Luckily, we came in and we talked to Dr. De La Luz. They saw very similar results in the study that they did, so I'll tell you the story about that as well. Unfortunately, I don't have a pointer, so I can't point at it, but if you just take a look at the nut set with the excluded trees and then the open trees, so the first graph that you're seeing, right, there is a significantly higher amount of nut set in those trees that the bees had access to, right? And then when we looked at the whole tree yields, that translated very clearly, and there was an increased yield. We did both wet weight and dry weight of the kernels, and there is an increased yield in those trees that had access by the bees versus those that were caged, right? So clearly, the people who said these almond trees don't need no stinking bees were wrong. And this is probably my favorite photo. This is really the real-life representation of the graphic that you just saw. So on on your left-hand side, right, those are the almonds that we collected from the trees that had no bees accessing them. And then on the right, we had almonds from the trees that had access, or the bees had access to them. So it's fairly obvious, right, that there's a benefit of having bees pollinate. Okay. We also did additional analysis. We took 100 nuts per tree, right, that we pollinated or that we used in the experiment per treatment. So we took 100 nuts and we had a poor undergrad do all of the measurements on these, and what we did find that there is a decreased kernel mass if the bees were not accessing, or if the bees were accessing these trees, which is not necessarily surprising because if you have a really high number of nuts on the tree has to reallocate resources in such a way, right, that it can produce all of these nuts, but they might be smaller. So that's what we did see. So again, that's not very surprising, but there were really no other differences between the two, or in the other case, the 3 different treatments. Okay. One big question, of course, is, okay, well, did we pay attention to honeybees? Can we confirm, right, that the bees were indeed visiting these trees? So we can say, yes, it is indeed pollinated by honeybees. So this was in year 2, 2021. The group of research technicians went out and they actually counted the number of bees over 5 minutes in these different orchards, right, at the same time, just to make sure to account for the environment, right? So they counted the number of bees in these different orchards in the morning and in the evening, and then we did the average, right? And as expected, we did see that there are fewer bees visiting flowers in the no hives treatment. Remember, we have ambient presence of bees, right? So just because we didn't put any on the orchard, in the orchard, that doesn't mean that there aren't any bees that are coming from your neighbor, right? We still had a presence of bees. And with the 1 hive per acre and the 2 hives per acre, we did have increased visitation rate. Between 1 hive and 2 hives, there was actually no significant difference, so it didn't really matter if you had 1 or 2 hives, okay? And then I'm not going to go through every single row here, right, I think you can see on your own, it's kind of bolded what the differences are, but there were clear differences, obviously, between the excluded trees, shade control, and then open trees. The open trees had the highest nut set, right, in 2021. There was really no impact of the shade control on the nut set, so the bees were still obviously coming to pollinate those trees. There was, however, no real difference if you had 1 hive per acre or 2 hives per acre additionally on those orchards, right? In fact, it looks like the 2 hives per acre might have ended up lowering the nut set. Could be potentially because there was a flood of bees, and we do note from some work previously done by Dr. Neil Williams that the flowers actually can get damaged. So there's such a thing as an optimal stocking rates, right? More is not always better. Okay, I think I've shown, right, that we definitely benefit from presence of bees, or you benefit from the presence of bees in your orchards. I'm not going to go through this, but I did want to point out that my colleagues, Dr. Delaluz and then Zach Ellis, they did have an economic model that they put forth that shows you what would be the benefits, right, of you renting the X number of hives depending on your orchard tree density, right, and what you're planning to accomplish. So in certain instances, if you do have some ambient background bees, for example, and then you rent a single hive, you do get a benefit overall of $144, or anywhere between $98 to up to $730 value, right? Additional value if you do put bees on your orchard. So limited time. This is available in the paper. Again, I'm going to leave this up in the front. You're welcome to come and take a photo. I completely forgot. I normally have the actual paper reference in the slide, but I forgot. So if you wanted to come up and take a look at this paper and then just take a snapshot of it so you can look it up on Google, you are welcome to do so. And then really, ultimately, what it amounts to is it's up to you, right, as a grower to decide whether you are willing to eat the cost of renting the hives in return for increased yield and in return for increased profit. So it was really up to you. And I have to say, I didn't put it up in the slide here, this was generated by ChatGPT. I'm not that good at it. And the ChatGPT graphics have gotten so much better. So this is what ChatGPT thinks an almond grower looks like. And of course, I want to thank the Almond Board of California for supporting this research. I do have additional data that I need to process. There were some questions about, well, what if you are excluding additional pollen from that one tree, right, that is in a single cage, a single tree. So we've done some additional work where we caged 3 trees versus just 1 tree in a cage, and we didn't really see any negative impacts of the actual cage. And then we did do some work additionally in Shasta as well, and the results are fairly similar. So we're working on that data. Hopefully that will be coming out soon. And I think that's it. Thank you very much.
Thank you, Elina. Just a reminder, we will take questions for any of the panelists at the end. I think you gave us the answer to your ChatGPT graphic there, which is that chart that you saw right before that. The take-home message is even accounting for the cost of 1 hive per acre, you still get a net return on investment that's quite interesting. So I think it's really important information for growers to consider. So with that, we'll hear from the beekeeping community themselves and some of the challenges they've been going to. I know there's always a lot of questions about the cost of pollination services. They've held pretty steady for a number of years now, but in the backdrop of that, the beekeeping community, like us, have been experiencing some tough times associated with profitability, pests and diseases. So I'll turn over to Matt. You're welcome to speak from there or the podium. I'll grab you the thing.
That's all right. Thank you. All right, good morning. As mentioned, I'll be doing a state of the commercial beekeeping industry nationwide for the United States. And I'll be presenting this largely from a perspective of biological and financial aspects of commercial beekeeping. One of the easiest ways to understand the biological challenges that beekeepers face currently is to break it down into four categories. We refer to these as the 4 Ps. They are parasites, pathogens, poor nutrition, and pesticides. And we're limited on time, so I'm just going to kind of cover these top line. When we talk about parasites, we're talking about varroa mites. I'll also mention we're encountering possibly some new mites. Pathogens will focus primarily on viruses. And when we talk about poor nutrition, we're talking about forage for bees. And I'll discuss that. And when I mention pesticides, I want to focus on surfactants, fungicides, and we'll also talk about miticide treatments for bees. So varroa destructor, enemy number one for the bee industry. We've had this problem for almost 50 years now, struggled with it almost on a yearly basis. This is a highly, highly successful biological insect. Replicates extremely fast, can move through a single site apiary very fast, can attach to bees and cover a large territory very fast. And with that, fortunately, the bee industry, we have essentially been approved for one chemical treatment in the last 20 years, which is amitraz-based. We can rotate that treatment with other, what we consider softer treatments, formic acid, oxalic acid, some essential oils. These are often temperature dependent and in general less effective. So the bee industry really is left struggling, trying to develop some treatment protocols that vary every year and something that we struggle with. What is encouraging is this year there has been 2 new products approved, Viroxan and Naroa. Viroxan is an oxalic acid-based treatment. Naroa is what you consider an mRNA treatment. Very new technology. It's kind of exciting to see what happens with that. It is also worth saying Naroa does not kill mites. So it is basically a mating disruptor, would be one way of explaining it for varroa. It's also very expensive. So we're looking at roughly the cost of $74 per colony per year to use this new product. Viroxan was just approved this year. It is worth saying that, unfortunately, the state of California was the last state in the United States to approve Viroxan for use. It's something that we've been needing for a while, and it's a process that I hope that we can work with DPR to really streamline the process for getting miticides approved. Elina mentioned, we had one of the highest winter mortality rates we've had in a very long time this year. We're averaging right around 62%. As scientists are studying this and as the data is coming in, what we're really learning is that a lot of that problem was due to amitraz resistance in varroa mites. So the understanding that we need miticides quick, we need alternatives, otherwise we're going to continue to struggle. So varroa is not the only mite that exists in the world. This is a letter from the State of New Jersey Department of Agriculture. Just last month, they actually apprehended a bee swarm at sea. Fortunately, it was 3,600 miles away from our shores, but it was an inbound cargo ship, and they found a swarm of bees on it. They killed that swarm of bees, and when they did their analysis, they actually found 2 different mites on that swarm, one of which was Tropolapsis mite. We refer to it as tropy in the industry because that's hard to say. This is a mite that's moving fastly through Asia, into Central Asia. It's now been found in Eastern Europe. It's basically going in the same path that varroa went in. And it's really, realistically, probably just a matter of time until this is something additional that we'll have to deal with. And is another reminder of the importance of getting more miticide treatments. So even though we've had varroa for roughly 50 years now, we're still learning about it. And there was some great information presented at the California State Beekeepers Convention last month that I want to share with you. It's a little bit dry, so I apologize in advance. It's a little bit complicated, but it really is impactful in terms of the quality of hives, the number of hives that we get in almonds. So in this first slide, we're going to use this to explain the next slide. We have 3 different colored bees. The beige one is essentially a bee that hasn't been parasitized. The green bee is a bee that was parasitized in the brood, and the pink was actually a bee that was parasitized by mites outside of the brood. Now, that pink bee is what we never really understood. So we know we can measure infestation rates in our colonies to some degree, but we really never fully understood how many bees those mites are feeding on. And Dr. Zach Lomas was able to do that in a great study. If we look at the right side of this slide, we see all the pink bees, and those were that's really what surprised me and a lot of other beekeepers, was the amount of bees those mites were feeding on once they got out of the brood. So if you look at, by the numbers, he determined there was a 14.6, essentially infestation rate would be a way of saying it. So if you round up, 15% infestation led to that mites feeding on 60% of the colony. That was surprising. What was also equally surprising was the fact that those mites, Varroa mites do have a preference for drone brood for a number of reasons. And so at a less than 15% infestation rate, that impacted nearly 100% of the drones in the colony. So just maniacal pest. And this is just another reminder also of the importance of keeping our mite levels down all year round. We can't let them flare up. So to that, detecting mites can be a little bit difficult. This was a great slide, also presented by Dr. Lamas. In the fall of the year, a lot of beekeepers find themselves assessing colony strength, looking at our colonies. Are we going to make it through winter? We look at our bee populations. An example of that would be on the left-hand side of the slide. We have essentially 2 boxes of bees, decent population. If we were to pull a frame out, examine the individual frame, again, decent population of bees. We look at that brood pattern. Oh, it's a relatively solid brood pattern. We know that it's queen right, and it would be easy to conclude that this is a healthy colony that's going to make it through winter, when in fact, this is a colony at a 40% infestation rate. Wow. So this colony is destined to collapse. And this oftentimes is what we're seeing when we do our fall inspections. So I mentioned how we can monitor for mites. Kind of the industry standard way of doing it is to put bees in an alcohol solution. Fortunately, that kills the bees, but it also kills the mites. The mites will detach from the bees, and if you look at the very bottom of the cup, we see some small black specks. Those are Varroa mites. And this is how we get our percentage of infestation. The best management practice is we want to keep our mites below 3% throughout the year. And going into winter, we want a less than 1% infestation rate in our colonies. So another way of saying that is a 90% success rate is an F in beekeeping. It's definitely a graded curve. And so it's very specific. We have to be very precise with some bad tools. Mm-hmm. So not only do mites parasitize bees, damage them, but even as and possibly even more importantly, Varroa is a vector for viruses. So as the Varroa is attaching to these different bees, it's also spreading viruses. And in the last slide, we talked about how there was still 40% of the bees that weren't impacted from Varroa. But in this instance, when you look at viruses, it's quite likely that the parasitized bees are then going to spread viruses to the rest of the bees. When you consider that bees do food sharing, they share food together, they feed each other, they live in close proximity. And so that would actually be an example of a horizontal spreading of viruses. Viruses can also be spread vertically, and that would be between generations. So if a queen was to become parasitized by a Varroa mite and get viruses, she would express those when she lays eggs. If a queen were to mate with a drone, and we talked about high propensity for getting viruses from Varroa, if she was to mate with a drone, we know that those viruses can also be transmitted in semen. So a lot of information, I know, but if we really want to narrow down in terms of beekeeper management, what we have to do to get bees and almonds and make grades, this is really what we're focusing on, is dealing with mites on a year-round basis and really assessing winter health to a pretty precise degree. So that was the first 2 Ps that I mentioned. We talked about parasites, we talked about pathogens, viruses being pathogens. The 3rd P I mentioned was poor nutrition. So Like all living things, bees need nutrition. How they get their nutrition is primarily through pollen and nectar. Pollen is their protein source, nectar is their source of carbohydrates. The nutritional requirements for bees are immense. So one colony annual requirement for pollen is about 50 pounds. So really just stop and think about that. A 50-pound sack of pollen per colony, they need about 100 pounds of honey to meet their carbohydrate needs annually. And unfortunately, what we're seeing in the bee industry is there's less and less places to do that, to place bees and collect and forage and get these things. Historically, a lot of some of the better areas in the United States are areas in the Midwest where they growers enroll in the Conservation and Reserve Program, we refer to CRP. And in that, they can designate parts of their farm. Oftentimes, the less productive areas, somewhat environmentally sensitive. They'll plant seed mixes, essentially a cover crop with legumes and a whole variety of flowers. Those have been great areas. And unfortunately, we've been losing those pretty fast. If we look at this graph, in 2007, there were 36.8 million acres of CRP ground enrolled, and that steadily declined all the way to 2022, where we're looking at now an enrollment of right around 22 million acres. So in that period of time, you're looking at a net loss of 14.8 million acres of some of the best ground for beekeepers to run their bees, and that's just a massive area. So if we were to look at the acreage for the entire Central Valley, this exceeds the landmass area of the entire Central Valley. So as this is happening, simultaneously, we're losing ability to place bees on public lands, federal, state, for a whole variety of reasons. They're kicking beekeepers off their properties too. And then when you factor in urbanization, some cropping shifts, some cropping patterns, every year, annually, we're losing less and less bees to meet our nutritional requirements for bees. One thing almond growers particularly can do to address this, they can plant cover crops in their orchards. Seed for Bees is an example of that. I would encourage you to visit their table here. This is something that is of benefit to beekeepers. It's also something that can directly benefit almond growers too. Having better colonies ready for pollination early will result in better pollination. So that fourth P, what I mentioned, pesticides. Since this is an almond conference, I just want to talk briefly about surfactants. So we add these to fungicide applications. There's a lot of information coming out recently that organosilicone surfactants have a detrimental impact on bees, and it's pretty significant. So I would encourage all growers, PCAs, to look at that and assess that, and there are some viable alternatives. This was a slide presented by Brandon Shannon. He's a PhD student at Ohio State. He studied this extensively. He's done a really good job. But if you look at the left side, high risk, the ones in bold are your organosilicone surfactants, and then there's some good alternatives on the right. I would encourage everyone to take a picture of that and just think about that, run it by their PCA. So that concludes the 4 Ps. So now we're going to go to kind of offer a financial snapshot of beekeeping. There's not a lot of good public available information on cost analysis for beekeeping. Fortunately, Brittany Goodrich, I think she was formerly with Davis, and now she's with the University of Illinois, and she does, I think, the cost analysis for almonds.
She does.
She's going to start doing a beekeeping one too, so I'm looking forward to that. But understanding that, the CSBA board, we actually did an internal anonymous survey where we all submitted our estimates, our cost to run a beehive annually for 2024, and we got right around a $350 average. And our cost structure, like the rest of agriculture, everybody knows, has gone up dramatically. One thing in particular is wages. The overtime changes in the state of California really adversely impacted beekeeping. In bees, we work during the day, we move our bees at night. Oftentimes, we're having to travel fairly large distances from our base of operation to service our colonies. And so it's something that's kind of hit us hard. So if you factor in that $350 cost, if we add our two most significant revenue streams, almond pollination being number one, and then honey production being the second, we're still struggling to pay costs, break even. That honey number, how I got that is I took the national average yield per colony nationally times the average price paid per colony nationally, and we got that 139.07. That average price of pound paid per colony was 269. Probably a little bit high, but the yield is probably a little bit low. So that's the beauty of averages. So
Still a low number to start with. Profitability.
I mentioned that honey production is a major revenue stream for us. The economics of honey production is somewhat interesting. You know, kind of where we're at right now is, you see it in this graph, we have declining production, and that's really reflective of just having less and less places to put bees nationally, so that really is not a surprise. We have declining production, but we also have increasing demand. Under normal circumstances, that would result in higher prices, but in beekeeping, that is not the case currently, and that's largely due to imports. You know, that black line that you see is the quantity of imports that we've been bringing honey into the United States, and it's pretty dramatic. And unfortunately, one aspect about imports, unfortunately, we are dealing with adulterated honey. There is a good amount of adulterated honey coming in, and that's really putting a ceiling on what beekeepers are getting for their honey. This is the most recent National Honey Market Report. This came out last month. This is currently 2025 pricing. We're seeing, you know, the price for honey in 2025 is probably is going down from 2024. I mentioned a national average for 2024 being 269. You see in this graph, you see a lot of, you know, low twos, even some sub-2 activity. And I think what we're going to see in 2025 particularly is we're seeing declining pricing, but we're also seeing declining yields too, is my estimate. So that's interesting. Part of the honey report is they also report on imports. And I already mentioned that imports have gone up significantly. India is now the largest exporter of honey to the United States. And I want to bring your attention to that, India. We're looking at bringing honey in, and this is actually fairly recently, you know, 99 cents a pound, $1.08 a pound, well below the cost of production. And just to be frank, I think the reason why we see that so low is, you know, some of that is adulterated. So honey adulteration is not unique to America. It's a global phenomenon, rather. When we look at instances in Europe where they've done some extensive testing, in this case they found nearly half of the honey they tested was adulterated. In India they did a test. You know, we're looking at 10 out of 13 honeys that they tested were found to not be pure, fraudulated to some degree. So that, you know, it's a major global problem. Honey is probably one of the most adulterated food items globally. Up there, I think olive oil is one, and surprisingly, milk globally is also another one. But I wouldn't say that's the case here. What is unique to the United States, though, is that honey is one of the few commodities that does not have a standard of identity. And what I mean by that is it does not have a legal definition. And that's something the American Honey Producers, it's a national organization. They're working on introducing legislation. It's called the Honey Integrity Act to actually adopt a standard of identity. But when you don't have that, you invite you create a lot of ambiguity and essentially invite adulteration. So that's where we find ourselves. So in summary, 3 things that can really help the bee industry. More miticides, we talked about that. More access to public land. Nutrition is essential. We just can't run bees without it. And I mentioned dealing with adulterated honey. The California State Beekeepers Association has recently published a white paper talking about this in a lot more detail. I would encourage everyone to Google that. Just Google California State Beekeepers Association white paper, and you'll find it on our website. And I just leave you with this graph. This is Dr. Zach Lamas. I mentioned him earlier in that presentation, doing some really good work, relevant, doing it the right way. And I just think there's a certain cruel irony in the fact that someone is doing what you want to do, but he's still having to set up a GoFundMe site to raise money for equipment for his lab. You know, honey, we need more money for research for beekeeping. There's no doubt about it. There's a lot of questions for which we don't have answers. I mentioned viruses briefly. Viruses is something that we just have very, very little understanding of, and it's really impacting our industry. So wanted to thank the Almond Board of California for the opportunity, and
Absolutely.
look forward to any questions.
Thank you, Matt. Yeah, really appreciate the data that hopefully demystifies whether or not there's a game on the pricing of pollination services, because there's real third-party data behind the cost and the profitability that the beekeepers are facing. So I think we recognize that this is a partnership between our industry and yours. And just to maybe touch upon a few of the things you mentioned there, the Varroa and pathogens, on Monday we just approved funding for a 3-year pilot area-wide project to look at whether we can get more effective control of Varroa and the associated diseases that it transmits through area-wide application of Varroicides. So given that almost all the commercial bees come to California, there's a window of time and a geographically contiguous opportunity to provide treatment before the bees go off to other locations. So an important investment that we've made. We've also invested in Project Apis M to work on helping facilitate registration of new Varroicides, because as we know, in trying to maintain our own crop, we need new products to come forward to ensure we don't get resistance, to address new regulations that we have that limit use of conventional pesticides. So that's an important process, and we do that for our industry and understand the need for almonds. We also work through the Almond Alliance to interface with our policymakers and regulators to make sure that they understand how important getting these registrations are. So we just last week talked about registration of Varroicides with DPR. On the forage, just want to double down on the incredible opportunity to get free cover crop seed from Project Apis M downstairs in the expo floor. Just one of the first tables on the left when you walk in. Go check them out. Free seed for the first year, subsidized for the second year, and then at cost for after that. So great opportunity to add forage. Also, there's Monarch Joint Venture and Pollinator Partnership, who have funds to help you put in out of the orchard forage, like hedgerows and the like. So definitely visit those. That will dovetail into Alexi's discussion. And then on the pesticides, the research that you showed about adjuvants and organosilicate adjuvants was actually funded by the Almond Board. So we take seriously that we have to use disease control fungicides during bloom. It's really important we understand what the impact will be on those bees. So we encourage you to not add adjuvants unless called for on the label. Don't do tank mixes, because there is research we've previously funded that showed that some compounds that are individually not harmful to bees in certain combinations are harmful, so don't tank mix. You should not need to use any insecticides during bloom. And then lastly, if you do have to apply fungicides, apply them in the early evening when the bees are generally not flying, so that you can ensure that you don't harm the bees directly. So honeybee BMPs, we're just updating those, but that's all research funded by the Almond Board to make sure that we do what we can to keep those bees safe so they can come back healthy the next year, so you get the best beekeepers bringing adequate bees for pollination. So important investments that you all make through the Almond Board. Yeah.
Yeah, I just want to say, too, that level of support is not new.
Yeah.
I think people need to understand that, too. I mean, the bee industry has benefited from decades of research support by the almond industry, and it's been just an amazing partner and collaborator. So I just want to thank you for that.
Yeah, well, it's in our self-interest. As we see, we get higher yields when we use bees. So last but very not least, we'll turn over to Alexi to talk about all that forage and habitat and how to make sure that you're legally protected in light of endangered species listings.
Yeah, so before I jump into the regularly scheduled talk here, I did want to touch on a couple things. You mentioned just the partnership between the almond industry and the bee industry. Bees will always have a special place with me, because it was one of the first issues that I dealt with upon taking over this role at the Almond Alliance earlier this year. I think it was my first week on the job, I was getting a call from some local government offices, and they said, do you know what's going on with this bee situation? I said, what's going on with this bee situation? So after many of phone calls, I learned that, beekeepers were experiencing a loss of hives upward of 50-60%, frames were down. And after many phone calls and many conversations and a crash course in all things beekeeping, I was able to identify a few key voices in the industry and get them in touch with the head of ELAP, which resulted in the release of funding to help those that lost the large amount of hives rebuild before this upcoming season. We're also continuing to engage with the bee industry, particularly on the tropicolaps issue. The idea is it's going to get here eventually, but if we can keep it out as long as possible while we allow a chance for the time for the research to catch up and how we deal with it, that'll ensure our growers access to bees and help keep the cost hopefully down. So anyway, it is very much a collaborative effort across the board. So with that being said, I'll jump back into what you actually had me come here to talk about today. So I'll give you a little bit of history before jumping in. Over the last few almond conferences, many of you have heard of the updates on the proposals to list monarch butterflies and several bumblebee species under the endangered species laws. These laws have the potential to shape how we farm, how we manage habitat, and how the industry responds to the growing focus on pollinator health. I'll first start with the bees. In 2018, a petition was filed to add 4 bumblebee species to California's Endangered Species Act. In 2019, the State Fish Game Commission granted them candidate status, meaning that they received endangered species protections while their status was still under review. The Almond Alliance, along with several other agricultural groups, challenged that decision. We argued that California law only allowed the state to list aquatic invertebrates, not terrestrial insects like bees. The county court agreed with us, but petitioners appealed, and the appellate court ultimately ruled that the law could be interpreted broadly enough to cover for insects to qualify. And when the state Supreme Court declined to review that decision in 2022, it effectively cemented a new precedent, and that was that insects can now be listed as endangered species in California. The monarch butterfly is on a slightly different track on the federal side. A petition was first filed back in 2014, and after years of review and court action and scientific evaluation, the U.S. Fish and Wildlife Service finally proposed in December of 2024 to list the monarch as a threatened species. Importantly, agricultural activities were not targeted for restriction unless they occur near coastal overwintering sites. Under typical timelines, we would expect a final decision to come sometime this month, but we don't anticipate that. These listings can often go about, a few months beyond, and if it stretches beyond that, we expect further legal proceedings that will likely set a new timeline. So we're still just waiting on feedback. So the question is, how do we as an industry respond? And luckily, we have not been waiting, we've been acting. In 2021, the Almond Board helped launch the Pollinator Coalition, which you heard a little bit about, the partnership of agriculture, conservation, and public agencies working to expand pollinator habitat through voluntary research-based approaches. In 2022, the Almond Alliance formed the Pollinator Alliance to help growers create and improve pollinator habitat on working orchards. We received a $2 million grant from CDFA to support this work, and we are still accepting new projects. So if you are interested, please stop by our booth in the Grower Incentive Zone to learn more. But perhaps the more important, and that was previously mentioned, is the Conservation Benefit Agreement. We are developing this with state and federal wildlife agencies, and its purpose is very straightforward. Growers who take good faith steps to create pollinator habitat and follow practical conservation measures will receive protection if incidental harm occurs to listed species during normal farming operations. This means that growers are not exposed to legal risk for farming as long as they're taking reasonable research-based steps to support pollinators. This work is being developed alongside a strong coalition, including the Almond Alliance, the Almond Board, Farm Bureau, Western Growers, the Strawberry Commission, Cattlemen Foundation, and the Wine Institute. It is a rare partnership that signals to regulators and the public that agriculture is willing to lead on conservation, not just be forced into it. Growers who choose to participate in the pollinator habitat would follow IPM guidances that reduce the risk to bees and implement practical steps such as drift reduction. And in return, their everyday farm activities that we're calling covered practices would be protected if incidental impacts do occur. We expect to submit a final draft of this agreement to the wildlife agencies in spring of 2026, which will then start the regulatory approval process. And while that review unfolds, our coalition will be developing outreach tools, establishing grower enrollment pathways, seed supply strategies, reporting frameworks, and budget structures to support participation. Then we're going to be working directly with growers, explaining how participation works, what protections it offers, and how almond growers who have already invested in habitat can build on that leadership to secure regulatory certainty. This is a great example of how agriculture is stepping up, and it shows regulators and the public that growers can enhance pollinator health while protecting their orchards, and that solutions work best when they are voluntary, practical, and built together. That's all I got.
Great. All right, yeah, so keep your eyes open for information from the Almond Alliance, the Almond Board, Ag Media, when this agreement is available for signups, which hopefully will be next year. An important opportunity to consider to provide you some legal protection while also helping demonstrate that almond growers and California farmers are part of the solution to a healthy ecosystem or a healthy environment here in California. So it's a really good, it's good for your farm, it's good for the industry's reputation, and good for pollinators. Again, an incredible amount of free resources that you can access through the Almond Alliance, Project APISM, Monarch Joint Venture, and Pollinator Partnership to help you put in habitat. So go down to that grower incentive zone because all of those organizations have free resources to help you there. So we have time for some questions. I think there's going to be a voice that's going to tell you how to use this QR code, but
Session includes dedicated time for audience questions. Submit questions specific to this session, and the QR code displayed on the screen. A Q&A moderator will review submissions and, as time allows, announce questions for the moderator and speakers to address.
so I am your Q&A moderator, if I can continue the radio voice there. Feel free to submit a question through that or just raise your hand. We can be informal, happy to take questions for any of the speakers on the important content today. I will moderate the Q&A. No questions yet. Feel free, raise your hand. You don't need to do that. Go ahead. Yeah. Yes. So you heard the question was if you have a self-compatible variety like Independence and you have no other almonds around you, is one hive per acre still sufficient?
I don't know if I stressed this enough in the presentation. I probably should have done a better job of doing that. Keep in mind, we've done this on a one plot basis or one orchard basis per stocking rate. So this is just the initial understanding of what the needs, pollination needs are of the self-fertile varieties. I would feel okay with saying, based off of what we know, 1 to 1.5. I'm not going to say 1, but 1 to 1.5. If you don't have any ambient bees present, 1 to 1.5.
Great.
Thank you.
Another question.
Questions for Matt here. I've got my beekeeper, he's out of state, so he puts a third of his bees every year in the potato cooling shed, breaks that brood cycle, and then fumigates and then brings them out. Is there anyone local doing that with off-season packing houses and cooling sheds in this area and having success with it?
There was one instance in Kern County where they tried that. They converted, I think it was a converted carrot storage facility, and the results were not good. It was unclear as to what exactly happened. There's a reason why a lot of that it's in Idaho. It's where they do the potatoes. They have that whole system of controlled atmosphere there, and so there's a whole economy oriented around that. I place my colonies. I have a North Dakota operation too. Everything from North Dakota goes into cold storage. There's a lot of benefit to getting that hive to shut down and break that cycle. And I think as time goes on, we're learning there are additional benefits too.
Yeah, I believe there's a queen bee breeder in the Sacramento Valley who does indoor storage here in California. But there's definitely a lot of good research, some of which we co-funded around indoor storage of bees as a effective varroa and cost control measure, as you say. But there are some requirements as to how the facility is constructed in order to get the full benefits. Other questions over here? Yep.
What research or experience do you have regarding complementing beehives with supplemental pollen applications in the field? And if it has worked, if you have a
Maybe I'll take this one. So the question was about supplementing honeybees with pollen application on the trees. And I'm just going to boldly disagree with some of the companies that may be present downstairs and that I see at other ag events. So we have never funded, that I'm aware of, any research looking at spraying pollen on almond trees as a supplement to honeybee pollination. I think if you look at the structure of almond blossoms and how they have to move the pollen from the stamens to the pistil, it is actually designed for insect pollination, for bees. There's a lot of evidence that honeybees and almond trees actually co-evolve throughout evolution. So wind pollination application, I think it's unlikely to work just given the structure of the bloom and the fact that you need an insect to really get in there and actually do the business to create a successful fertilization. So, but we have funded no research on that I'm aware of. Yeah.
Sorry for, it might be a naive question. Can we relocate hives throughout the blossom season to ensure that they have maximized visits throughout the entire orchard?
So this is around hive placement and whether you can move the bees around. It's an interesting question, and there's some research out of Australia, and there's, I think, some growers who've experimented with this in their own orchards about where placement, how you place the hives can make a difference, like more even distribution, or I think you're asking about even moving them around. We don't have any research to that effect. The work that I have seen suggests that, more distribution of the hives is beneficial. Yes, the bees fly, but, they're a little lazy. If there's good pollen and nectar, they're not going to fly as far. It's always going to be a trade-off on the economics, and I'm sure Matt can address that. It's labor to place the bees and move the bees, and so there's always going to be a trade-off on that and the cost of that labor if you're going to try to distribute them more. I don't know if you want to comment on that or not, Matt, but we don't have any research in California to that effect.
In terms of bee placement, I think the most important variable is morning sun.
Yeah.
So, you got to remember February, March, still cold that time of year. Typically, bees won't get out until it's about 50 degrees, 50, 55 degrees. You put bees in shade, you could be losing a significant day to pollination. So getting that morning sun, getting bees on, typically east side, southern edge of an orchard are tend to be somewhat preferential.
Yeah.
And bees will fly. I think people like to, an orchard is a grid pattern, and we want this even distribution over this grid pattern. But if that means putting bees in shade, then you're not really accomplishing anything.
Okay, so we have some questions from online. Here's some questions. What is a fair contract between beekeeper and grower for minimum frames? I'm going to read these all off, and people can take note on the panel. What have you found on herbicide effects on bees? And can we relocate the hives during bloom? We've got that question. So, fair contract between beekeeper and grower on minimum frames and herbicides. I don't know if you want to talk about minimum frames, or I can.
Yeah, in terms of the industry standard is typically an 8-frame colony, 8-frame average, and that's per frame would be covering 70% of the frame at a minimum of 60 degrees. So that cluster will get tighter as it gets colder, loosen up as it gets warmer. And so grading bees is a bit of an art form. Mm-hmm. How many bees are in the orchard, things like that. In my contracts, I just like to go by an 8-frame average. An average is an average.
And that's 8 frames per hive or per box, as what most people would think of it.
Yeah.
So if you have 2 boxes, you're talking 16 good frames of bees with coverage of 70% of the frame with bees at 60 degrees. Yeah.
Some people put a 4-frame, 5-frame minimum in the contract also. I feel it's unnecessary. If you're meeting your average, then minimums kind of take care of themselves, and it's a little bit simpler.
Great. And that's what the research that the Almond Board funded, I think in the early 70s is when we got that number. And then a question around herbicides. We have not done any research on herbicide impacts on honeybees. We hope most growers are not needing an herbicide during pollination time. Keep in mind those bees are not present in the orchard for that long. And you should not need to be applying herbicides during that period of time. So hopefully that's not an issue we would encounter. Can you use mason bees to complement honeybee pollination? Yes is the answer. There is some research that we funded looking at blue orchard bees as a supplement to honeybees. And it does show improved pollination, bee visitations, I think is how they were measuring this. I'd have to go back and really look at whether they measured yield. So that is an option. You just then have to deal with your contracting for 2 sets of bees. And I think for most growers, that's more complicated. And that's why we haven't, some growers do this. The mason bees or blue orchard bees, any of the bumblebees, tend to fly at more colder temperatures or more inclement weather, rain. So that's the theory as to why. And they also compete with the honeybee, and sometimes competition makes the bees up their game a little bit. I think that's what the research shows. Again, it's just a question of do you want to contract for 2 kinds of bees? A question of, was there a bee shortage in almonds in 2025? So we don't survey growers on this question, so I don't have consistent, statistically significant data. We did hear from a number of growers anecdotally that they did not get the number of frames that they contracted for, so that people were coming up short on frames. If you look at the expected total industry production this year, which is not likely to be the number we got in the objective estimate if you've been following that drama. There's no indication that the high losses of bees has had an impact on almond yields this year, but there are so many factors that go into almond yield, and there's many of those factors were in our favor this year. We had really good weather during pollination season. Growers have been able to put more of their normal agronomic effort into the orchard as they return to profitability. So as an industry as a whole, we cannot see the impact necessarily this year on those high losses. However, we know from history when colony collapse disorder hit and almond acreage was increasing that we did have challenges meeting our pollination needs. And of course, if beekeepers continue to experience high losses, their profitability is in the tank, and some of those beekeepers may not survive. So whether or not the total health of the beekeeping community is sufficient to meet our needs in the future is something we do take seriously. Okay, I think that's, we've answered all the questions, and we're now a couple minutes over. So let me just thank all of our speakers again. I'm sure some folks would be happy to answer questions if you want to come up afterwards, but thank you again for joining us today and sharing your information.